This is a video for 11.7, areas and volumes of similar solids. So we're going to talk similar solids today. Similar solids have the same shape, so they're 3D shapes that are both cylinders or both pyramids or whatever, and all the corresponding dimensions are proportional. So that is talking about a scale factor. That means that they have the same proportional scale factor between the sides, which is A to B, which we've talked about before as a ratio of perimeters. Okay? If you get two cubes together, they're going to be similar. If you get two spheres together, they're going to be similar because they each respectively only really have one dimension. So that scale factor will always be the same. So here's a good example of what this might look like. It says, are the two rectangular prisms similar? If so, what is the scale factor from the first to the second? So what we would want to do is line up sides that correspond. We're checking if the corresponding linear dimensions are proportional. So we have one side that's 3/6, which simplifies to 1/2. Then we have like the bottom sides, which is also 3/6, which simplifies to 1/2. And then we even have the depth of it, which is 2 to 4, which is also 1/2. So each time we end up with a 1/2 for that fraction. That means that all the corresponding linear dimensions are proportional, like it's saying right in here. Okay, which means yes, the rectangular prisms are similar. And then it says, if so, what is the scale factor? The scale factor is A to B, which is 1 to 2. So we might get some questions today about just wondering if whether or not the two solids are similar. Let's look at this one here. All right, again, I could start with these two. So I have a 2 to 3, which is already simplified. I'm looking for 2 to 3 the entire way through. So the bottom is 3 to 6, which simplifies to 1 to 2. These two are different already, which means no, they're not similar. If you wanted to explain, you could say that 2/3 does not equal 1/2. Okay, one more time with these two cylinders. It says, are the two cylinders similar? If so, what's the scale factor? So we could check each radius. The ratio of the radii are 6/5. And then we could check the heights of the cylinders, which is 12 to 10. But 12 to 10 does simplify to 6 to 5. So we have the same scale factor for both, which means we do have similar figures. The scale factor is going to be equal to that A to B, which is 6 to 5. So just working through whether or not they are similar, that should go pretty well. The stuff that we have to remember how to do is do some of the solving, which we'll get to in just a little bit. So if you look through this problem here, we have two similar rectangular prisms. If you look at the scale factor of these, so this depth is 1, this is 2. The scale factor is 1 to 2, which is A to B. All right, for every 1 inch on the left-hand prism, the right-hand prism has 2 inches. If you went to get the surface area of that, they did some work for us. They're telling us the surface area is 22 of the smaller one and 88 of the larger one. So that's this 22 to 88, which simplifies to 1/4. That's an area. So remember what happened. This is like a ratio of perimeters, which is 1 to 2, A to B. We have A squared to B squared for that ratio of the areas, which is something that we've talked about before. If the area is in square units, the ratio of the area should be A squared to B squared. Then when you go get the volumes, remember how this works. So you can get the area of the bottom, which is 2. 2 times 3 is where they get that 6. Down here, you can do 4 times 8 to get 2, and 8 times 6 is where they get this 48. So the ratio is 6 to 48, which simplifies to 1 to 8. But if I could have just done A cubed to B cubed right away, I could have gotten from my A to B, which is 1 to 2, up to that A cubed to B cubed. So the whole way through, we have this ratio going on. So the ratio of the side lengths becomes really important. What is A to B? If I know A to B, I can get the ratio of the areas, or I can get the ratio of the volumes if I just remember a couple things. So here's something for your formula sheet or your note card then. It says if the scale factor of two similar solids is A to B, then make sure that you have this stuff, the ratio of their corresponding areas is a squared to b squared. Remember, area is in square units, so the ratio should be a squared to b squared. The ratio of their volumes is a cubed to b cubed. All right, the units for volume is cubic units, so that ratio should be cubed. So really it comes down to, do we know this a to b? If we know this a to b, then we have a really good shot at figuring out anything that they might ask for. Okay? Here's what this one says. The square prisms at the right are similar. What is the scale factor of the smaller prism to the larger prism? So they want the scale factor, which is the ratio of the perimeters, which is a to b. And then they want the order of smaller to larger. So they want the smaller one written first. So with this one, they gave us volumes. I don't have any side links at all, so I can't just look at the shape and say what the scale factor is. But they did give us volumes of the smaller and of the larger. So what they did was give us a ratio of 729 cubic centimeters over 1,331 cubic centimeters. We have to remember, since those are volumes, the ratio that they gave us is a cubed to b cubed. So what we want is a to b. We want to figure out what a to b is, which means we don't want a cubed to b cubed. We have to get rid of those cubic units. So just like we talked about yesterday, going from volume to surface area, the way that I could get from cubic units back to linear, just regular centimeters, is take the cube root. So I'm going to take the cube root of everything I see here, and that will help me get that a to b that I'm looking for. So a to b is now the cube root of 729, which if you punch in your calculator, you get 9. And the cube root of 1,331, which is 11. So now these are in centimeters. This is already simplified, so that would be my scale factor, a to b. So if they would have given us area, we could have just taken the square root. But since they gave us volumes, we had to take the cube root. All right, so like this one here. This one says, what is the scale factor of two similar prisms with surface areas? So they gave us areas this time, which are in square units. What they gave us is 144 to 324 as a ratio. These are in square units. We want to get a to b from that. So if 144 over 324 is our ratio, you can check the units if you're not sure. Right now we're talking a squared to b squared, and we need to get that into a to b. So the way we can cancel out the a squared and get a, and the b squared and get b, is to take the square root. So if I take the square root on the right, I'm going to take the square root on the left, and I'm going to get the square root of 144, which is 12 meters, square root of 324, which is 18 meters, and then this answer would be good. We're just going to simplify it a little bit. 12 to 18 would simplify it down to 2 to 3. Remember, we want that scale factor completely simplified. Okay? So the last part of the video, we'll be looking at solving some problems with that, so that what's going to happen is now our a to b is going to be more like our first step. So we'll go to the next page and continue there. All right, so now we are using a scale factor. Using the scale factor to find either a missing volume or a missing surface area. Here's what this one says. The lateral areas of two similar paint cans are 1,019 square centimeters and 425 square centimeters. They're going to give us the volume of the smaller can, which is about 1157. We'll come back to that in a second. They want the volume of the larger can. That's what we're looking to find. So, on your note packet, this is broken down into a few steps. The first step would be to find a to b. That would be like step 1. What they gave us would be two areas, the lateral areas. So they gave us 1,019 and 425. Those are square centimeters. That's an a squared to b squared. All right, what we need is we need to get a to b so that we can figure out a cubed to b cubed, so we can set up a proportion and cross multiply. So This is going to remind you a little bit of some Chapter 10 topics that we had. Problem is the numbers here aren't very convenient, but we can work around that. We need to take the square root of each of these to get back to A to B. Okay? If I take the square root of 1019, let's just do nearest tenth, about 31.9. The square root of 425, about 20.6. All right, so what we end up with there is A to B. We needed that for step 1. We need to take that and use it. So step 2 will be use A to B to find volume. But to find the volume, remember that that's A cubed to B cubed. So we need A cubed to B cubed, or we need what we just said, 31.9 to the third power over 20.6 to the third power, because like I said, volume, that's A cubed to B cubed. That's what we're looking for. All right, so with that, we can get that A cubed to B cubed. So pretty big numbers here, but 31.9 cubed, about 32,461.759 over 8,741.816. So that's our A cubed to B cubed. Now that we have that, we are going to set up our proportion with that. So now we can take what we were given, what we just found, and then add in what we were given. So 32,461.759 over 8,741.816. We can set that equal to, and now since we're in the correct units with the correct proportion, we can look at what they gave us. So they gave us 1157, which is a smaller volume. So since 8,000 on the bottom is smaller, I'm going to put the 1157 on the bottom. We're looking for the larger one, which means we'll put the X on top. So this is a cross multiply problem, and then we're almost done. So we're going to take that 32,461.759, and we're going to multiply that by 1157. We're going to set that equal to 8,741.816 times X. All right, on the left-hand side, we're multiplying, and then we are going to divide by 8,741.86. So I'm just going to do that in one step so we can do the calculator step all at once. Okay, divide both sides by 8,741.816. Okay, then I cross out on this side. So I have my final X answer once I go to the calculator. 32,461.759 times 1157 divided by the 8,000 number. You end up with about 4296.39 cubic centimeters. We'll try another one with a little bit of nicer numbers so that we can see exactly how that goes. But really, the steps are going to be the same. They started us with surface area they started us with volume, instead of surface area. So we're going to work back and get that. So they gave us volumes in cubic meters. We need to make our step 1 to find A to B. So we need A to B. They gave us A cubed to B cubed, which was, I scrolled down a little too far, 128 over 250. Okay? I'm actually going to look at simplifying that right away. To get A to B, we're going to cube root. But before we do that, I noticed that 128 and 250 can get smaller. I can divide them both by 2 and simplify. I'll just write that just for your notes so you know what we did. We did 64 over 125. That's just dividing them both by 2. Now, if I use that as my a cubed to b cubed, it's much nicer when I go and take the cube root. Because 64 is a perfect cube, and so is 125. So remember, you might need to know where that button is on your calculator. But the cube root of 64 is 4, and the cube root of 125 is 5. 5 times 5 times 5. So we needed this, a to b, but what we want to answer is a surface area, so that's going to be a squared to b squared. So right away, I'm going to turn that into 4 squared to 5 squared, which is a squared to b squared now. So that would give us, what, 16 over 25, which is our a squared to b squared. I'm going to take that a squared to b squared then and set up a proportion with it. So the number they gave us is the larger solid of 250 square meters. So I know the larger solid is 250. So I can go 16 is to 25 as they gave us the larger one, which is 250. So that goes on the bottom with the bigger number. X goes up top. At this point, we can cross multiply. 16 times 250 equal to 25 times x. You can do that 16 times 250 first if you want. Once we divide the 25 over, 250 and the 25 are really going to make a 10. So it's like 16 times 10 or 160. This is a surface area, so square meters is that missing one. All right, so with these steps, they can take some time, but that's what we're looking to do. All right, this last one is more of a word problem version of it with this, this milk bottle shaped building. So you can compare capacities and weights of similar objects. The capacity of an object is the amount of fluid the object can hold. The capacities and weights of similar objects are made of the same material are proportional to their volume. So if you get a capacity problem, treat it like a volume problem, a cubed to b cubed. Excuse me. So again, we're going to get a bigger number here, but that's all right. So I know that a bottle that is 10 inches high holds 34 ounces of milk. That's kind of like my capacity or my volume. The sandwich shop shown at the right is shaped like a milk bottle, so we're going to say that they're similar. What I have here might be hard to read on your paper, but 480 is the height of that building in inches. They want to the nearest 1,000 ounces, how much milk could the building hold if we filled it with milk? So I know that I need a to b, and I need to use that to get a cubed to b cubed because a capacity of 34 is like a volume. So a to b, right now I know that my actual milk bottle is 10 inches while the building is 480. So that's going to simplify to 1 to 48. If I want to convert that into a cubed to b cubed, that would be 1 cubed to 48 cubed, which is 1 to, let's see, what did I write down for that? 110,592. So that's the ratio of the volumes of the milk bottle in real life to the building. So I can use this number to get my capacity of the building. So 1 over 110,592 is equal to the capacity of the milk bottle, which is 34, over the capacity of the building, which is what I want. So I can cross multiply. So x, 1 times x, will equal 34 times 110,592. In other words, x is equal to 3,760,128 ounces. They want us to round to the nearest 1,000 ounces, so I would round it down to 3,760,000 ounces approximately. Okay. So you got to talk about, if you're looking at these word problems or these ones where you're looking for a volume or a surface area with these similar solids, Do you need a cubed to b cubed, or do you need a squared to b squared? Most of the time you're going to need to find a to b to help us with that. All right, so I'll let you work on the worksheet now. Go ahead and get started with that. And that's going to conclude all of Chapter 11. So one Chapter 11.